What is love? Baby, don't hurt me no more. Baby, don't hurt me no more.
Hello, Chemistry 30. This is our third lesson in the organic chemistry unit. This is aromatic hydrocarbons. In this lesson, we will explore aromatic hydrocarbons, learn how to name and draw aromatic hydrocarbons, look at classical nomenclature, and work through 4 examples. Aromatic hydrocarbons contain benzene structures. Benzene, which has the chemical formula C6H6, is a cyclic structure of 6 carbons with a circle drawn in the middle to indicate the equal sharing of the 6 unbonded valence electrons. A benzene structure is typically given the illustration below. It's important to note that all the bonds between the carbons in this structure are the same length and strength. Benzene structures are considered saturated molecules. Each of the following illustrations below represent benzene structures. We've already seen the first on the left, which is a hexagon with a circle drawn in the middle. In our middle example, this is a more accurate structure of a benzene molecule, where we actually have 3 double bonds within the 6 carbon ring. Now remember, these unshared electrons are not located between the carbons with the double bond. They're actually shared amongst all of the carbons in the molecule, giving each of the bonds the same strength and length. That's why benzene structures are considered saturated. And finally, our illustration on the right is also an example of a benzene structure drawn in a line diagram with, again, the 3 double bonds. Benzene as a branch. If a benzene ring is attached to a carbon which is not at the end of a chain, then the benzene is considered a branch. It will be called a phenyl branch. A phenyl branch has the chemical formula C6H5. Below we can see an example where the benzene structure is located on a carbon which is not at the end of a chain. Therefore, we would consider this benzene a branch. Remember, branches are listed in alphabetical order. Provide a number location for all branches. Include prefixes if there's multiple, for example, di and tri. The name of the molecule below is 3-phenyl-4-propyl octane. Now this may look a little different, but if we count the number of carbons in the longest carbon chain, we have 1, 2, 3, 4, 5, 6, 7, because of the subscript 3, and 8. And numbering it from the side that gives all branches the lowest values, we have 3 for the phenyl branch and 4 for the propyl branch. Notice the 3 carbons. Phenyl, pH, comes before propyl, PR. Benzene as the parent. If the benzene ring is attached to the end of a carbon chain, it becomes a parent and is named as an alkyl benzene. No number location is required if there is only one alkyl branch attached to the benzene ring. That is because that branch will always come off the first carbon in the ring. If more than one alkyl branch is added to the benzene ring, the branches are given the lowest numbers possible. And remember, they are named alphabetically. The name of the molecule below is methylbenzene. That is because our parent is the benzene structure, and we have one carbon branch coming off of the benzene structure, which will be a methyl. Classical nomenclature. Benzene rings that have two branches in the 1,2, 1,3, or 1,4 orientations can be denoted by the prefixes ortho, meta, and para. When there are two branches in the 1 and 2 locations on the benzene ring, it can also be known as O for ortho if the branches are located on the 1 and 3 carbons in the ring. It can be also known as meta or M. And if the branches are located at the 1 and 4 location on the parent ring, it can also be known as para, P. Drawing aromatics. Again, just like every other hydrocarbon, start from the back of the chemical name. You have to make sure your benzene is either a branch or a parent. The structures will look very different. And remember, start by drawing your carbons, then add your hydrogens after. Example number 1. Name the following aromatic hydrocarbon. Pause the video and attempt this example. First, we can notice that both benzene structures are not at the end of a carbon chain. Therefore, they should be named as branches. We now have to find the longest carbon chain that includes the double bond. And this will be 1, 2, 3, 4, 5, 6, 7, 8. And we want to number that carbon chain from the end that gives the double bond the lowest value. Therefore, this will be our 1, 2, 3, 4, 5. We have 2 phenyl branches coming off the 5th carbon in the chain, and we have a single carbon, a methyl branch, coming off the 3rd carbon in the chain. Our name is 3-methyl-5,5-diphenyl oct-1-ene. Don't forget diphenyl. That is because there are 2 phenyl branches. Example number 2. Name the following organic molecules. Pause the video and attempt this example. In the first molecule, we can see that the benzene ring is the parent. Therefore, we just have to name the branches that are off the benzene structure. We have an ethyl branch located here and 2 methyl branches. What's important is that all branches need the lowest value. In order to accomplish this, the ethyl branch should be given the first carbon. This methyl will be given the second, and the last methyl will be given the fourth, giving us the name 1-ethyl-2,4-dimethyl benzene. Again, the benzene structure is the parent, so benzene will be at the end of our nomenclature. In our second molecule, notice how there is not a circle within the ring structure. Therefore, this is not a benzene. This is simply a cycloalkane with 1, 2, 3, 4, 5, 6 carbons. There is also 2 branches coming off the ring structure. A methyl branch located here and an ethyl branch here. Either one of these branches can be given the first carbon, while the other has to be given the third. In our example, we have named the molecule 1-ethyl-3-methyl cyclohexane. Again, note that the 3 and 1 can switch spots because it would still give all branches the lowest possible value. Example number 4. Draw the line structural diagram for 1-ethyl-3-methyl benzene. Pause the video and attempt this example. By looking at the molecule name, we can tell that the benzene structure will be the parent. Therefore, it will be at the center of our molecule. We also have 2 branches. At the first carbon, we have an ethyl branch, which can be here. And at the third carbon, we have a methyl branch. The other 2 molecules are the exact same structure. What we are illustrating is that they're all correct. You're just looking at each molecule from a different perspective. Moving forward, we will explore physical properties of alphatics.